today's objective is to learn about topographic maps. Your essential question is, how do topographic maps show land features that are created by both plate tectonics and weathering, erosion, deposition? Which today what we're going to look at, or we're going to focus on, is plate tectonics. Tomorrow we'll look at weathering, erosion, deposition. Which means that these notes are 2-day notes. You're going to add to these notes tomorrow. So you will probably end up with a flip page, but probably not today. So, looking at what topographic maps is. Okay? Basically, all a topographic map is a map, obviously, that show you physical characteristics of the land or the area. Specifically, or examples of things that a topographic map can show you is definitely elevation. Every topographic map is going to show you the elevation of the land. It can show you trails, like if it's a camping area, it'll show you the trails that you can walk on. It can show you where the rivers are, where the creeks are, campsites. Basically, any major physical landmark is shown on a topographic map. So, like if you were going to go out hiking, a topographic map would be a good thing to carry because it's going to give you landmarks that you would want if you're going hiking. It's also going to give you elevation, which means that you're going to be able to figure out what is the best trail for you. Do you want an easy hike? Do you want a hard hike? So you start looking at different land features, and the topographic map is going to give you that information. Now, the major thing that we're going to focus on is looking at how topographic maps show you elevation. And the way they do that is through what we call contour lines. Contour lines are just basically lines that show you the elevation of the land. The way those contour lines are being made is through land surveys. They'll go out and they measure every so often what the elevation is at specific heights. So let's say every 5 miles up, they basically take a reading all around the area to see the elevation at that point and see what the land actually looks like. So what we're going to do is I'm going to do a little demonstration that shows you basically how they would survey a piece of land. But obviously it's going to be a model. So, the rest of your notes are basically to take notes over the demonstration. Okay? What am I doing? What does it look like? And I'll guide you as we go along. So, your rest of your notes should be over what we're looking at up here. Alright? Now, I have a mountain of clay. Okay? So, if you look at it, it's a mountain. I'm going to give you a side view of what it looks like. I can bring this back a little bit. Alright. So, basically, it's a mountain. You can see what it looks like. Alright? It's not a regular mountain, so one side is steep, one side is not. So basically what they'll do to make a topographic map is they will measure up a certain height, and they will kind of measure up on this side, and then they end up getting a picture of what it actually looks like. Okay? So when they do topographic maps, basically what they do is they measure up, and then they do kind of like a cut. And then they measure up, do kind of like a cut, whenever they're actually drawing their pictures. So, if I want to draw a topographic map of this mountain, okay, what I will do is, or what I already did because it takes a while, so I did it beforehand. What you do is I took a measuring tape and I measured up 1 centimeter. I measure up 1 centimeter here, one here, one here, one here. And then I cut that off. and then I did another centimeter, so I went up 1 centimeter, okay? Then when you do that, you're able to go in and take the pieces off separately of 1 centimeter in height. So you're able to see what the landmarks or what the land looks like at 1 centimeter in height as you go up this mountain. So obviously they're not able to take it apart like I did. But what ends up happening is you end up making a topographic map from those sections that they're coming back up. So what they end up making is something that looks like this. So the way I did this is I took this and I basically just put it on a piece of paper, traced. Then took my next section, put it on a piece of paper, traced, and so on and so on. So that mountain is represented by this topographic map. Okay? So, first, this is what you want to do. You will get a copy of this and you're going to be able to trace it in your notebook in just a second. But right now, I want you to take about 1 minute and I want you to write observations over that topographic map. So, write observations over what you see, anything you see in that map. So in your notes, write observations of the topographic map. What are you noticing? I'll make this a little bit. So write a few observations of what you see. All right, Tristan, what are some of your observations? Give me one.
Each piece is cut smaller and smaller.
Of that?
Oh, they're layered by numbers.
Okay. Yes, I.
On this side, which I'm guessing is the steeper side, the lines are closer together. The other side, the less steep side, the lines are further apart.
Okay, so lines close together, lines further apart, very good. Something else? What do you have? Any observation or anything that you find? Right here?
Yeah.
Okay, and that's 5.5. Okay, what else? Yes?
One side seems to be leaning toward the other.
Yes.
Same height.
One side seems to be leaning towards the other, alright. What else? Antonio?
The sides are never, like, the thickness of it's never equal.
Okay, thickness is never equal. Very good. Alright. Jose? Observation is just that picture right there. Okay, tops seem closer than the bottom, okay? Alright. Wow, nobody's noticed something fairly big and very different. Yes, Aaron.
Every layer has a different shape.
Every layer should have a different shape, very good. Alright. Something else, yes. That's from the top view, very good. Yes,
Same right there. Yeah,
what thing?
right in front of between this house.
No?
Yeah.
Very good. It's very, this part right there is very different than everything else. Does anything else have little lines like that?
No.
No? Okay.
What is it?
Alright, you're about to.
Oh wait, where?
What do you think it is, Ivan?
Creator, it was volcano.
It's a crater. So, this is what it looks, the topographic map looks like, right? So now, looking at the actual mountain. Okay, this is it right here, right? So, basically, this is the way it's drawn. So one of the things that I heard was Ivan said that these lines were closer and these were farther away. Okay? And Ivan actually made the correct connection. What was your connection to closeness to far away?
Steeper and less steep.
Very good. Steeper, less steep. You can see that this side is steeper than this one, right? So if you wanted to go hiking, which way up the mountain would you want to go hiking if you wanted an easier hike? Less steep, right? So all you have, because obviously you don't have this picture in your head, you have this. So looking at this, you would look for lines that are closer together or farther away? Farther away. So if you saw this, it's like, well, and there was a trail going here and there's a trail going here, and you want an easy hike, you would choose this trail, right?
Yeah.
Okay, alright. So this right here, okay, it's a circle, but they're going in to the bottom. And the reason for it is because sometimes you have something such as a crater. In this case, this could be a volcano, right? So this right here could be the crater of the volcano. But it doesn't necessarily always have to be a volcano. It could be that it's a mountain that's, have you seen mountains that kind of have just dips in there?
Yeah.
It could be a dip in the mountain. Okay, so it could also be that. Alright. Y'all notice this right here. It said, oh, there's something right here in the middle. Now that says 5.5. That is the peak of the mountain. So your middle circle is always going to be your peak, and that's always going to have a number inside it, and that's the highest elevation. So in this case, it was 5.5 centimeters. But let's say this was a real mountain. Obviously, it's not going to be 5.5 centimeters, right? So what they'll say is that for every 1 centimeter, it's 100 kilometers. Okay? So if I said that 1 centimeter is 100 kilometers, how tall is this mountain? 550 kilometers. Okay? Now, the other thing they might say to you, because we already said this is less steep, this is more steep, right? Closer together is more steep, farther away is less steep. The other thing they might say or ask you about these topographic maps is thinking about elevation and you understanding where things are. If I come in and I say that I'm going to build a house right here, and I'm going to build a house right here. And then a flood comes in. Which house is going to get flooded first?
The one on the steep side.
The one here?
Yeah.
Or the one here?
And then there. With the mudslides and things like that.
Okay, so who thinks this one? Alright. Alfredo, why do you think it's going to be that one? No, but we're just talking floods.
Oh.
Not
Water
mudslides,
comes-
it's
water
flood.
comes down and like it could, better chance of knocking the house down faster than.
No, but listen to what I'm saying.
Flood.
Not mudslide, flood, meaning the water is going to come in your house.
Oh.
Not the mudslides. The house is going to be intact, but it's going to be water in it. I saw David. Why do you think that one's gonna flood
This
first?
is lower, isn't it?
Okay. Who's saying is this one? Yeah, Ivan, why do you think this one's gonna flood first?
Since it's less steep, this one's not as high as the other one, the one in purple.
Well, didn't I say that these numbers should give you elevation, right? Alright, so this is 1, and this is 2, right? So this x is in between 1 and 2. Correct?
Yep.
This x is between 1 and 2. Correct? Alright. This one
It's farther from
is farther from 1. This one is closer one. So which one's at a lower elevation?
one.
The left side.
So which one's going to flood first?
And you know you can
Now, what if I said, okay,
say,
that I have another house right here. Now which one's gonna flood first?
No, the right side, cause the one is, on the left side it's above 2 and the right side is right under 2.
Very good. Isn't this one above 2?
Yeah.
And this one's below 2, so this one's going to flood first. So does the steepness have anything to do with it in that matter?
No.
What do you need to look at if you're looking at that type of scenario? The elevation, only the lines, okay? And the reason I'm saying this because there's a question in the past where it looked like the house that was going to flood was closer to the edge, but it was up higher because the lines were really close, okay? And the students looked at the closeness of the house to the edge and not the lines. So make sure you look at the lines, okay? So, any questions over that? So in your notes, you should have something about the lines being close together. And if they're really close together, what does that mean? Steep. Lines really far apart? Less steep. Alright? What do the lines give you?
elevation.
Elevation. Okay? And your peak is always at the top. Now, this right here is always based on elevation above or below sea level. So since this is 0,
That's
that's sea level right there, right? So what is this?
above.
It could be a volcano, yeah. But is this on a continent?
Yeah.
This is an island. Isn't it 0 all the way around? So isn't it surrounded by water?
Yeah, cause it's
That
at sea
tells you
level.
that's an island. Now, what if my first number wasn't 0? What if my first number was 50?
And it would be a
Then
land.
it's a land, it's a mountain, you don't know exactly where it is. But this one for a fact is a island, because it's 0 all the way around. So, if this is a volcano and it's an island, what type of plate tectonic plates, what type of plate boundaries can make this?
Two oceanic.
Not convergent.
Seduction.
Diverging or
Two oceanic plates go together and.
It could be 2 oceanic plates, divergent. So it could be divergent,
And it could
She
be.
said it.
it could be convergent, but it has to
Oh.
be specific
Oh shit.
oceanic plates.
That is
I had said
Okay.
that.
So, I'm sorry, Ann, it could be convergent, but you have to be specific to the point where it's oceanic plates. Because since it's surrounded by water, it couldn't be oceanic continental, because continent would be there. Okay?
Converging underwater
Convergent of water, yes.
with no land mass. No water.
So, any questions over that? Alright. We're gonna do an activity. While I set this activity up,